Hi, good morning. We are Group 11 and we are here to talk about Johannes Kepler. Before I start, let's talk about who Johannes Kepler is. He was a German astronomer born December 27, 1571, and he died November 15, 1630. In his early life, he studied at the University of Tübingen, where he went on to study mathematics. He was also closely following the studies of the Copernican theory. Other contributions that Kepler was also responsible for were how the eyes enable depth perception. This made it possible for him to make eyeglasses for near and farsightedness. He also discovered that the moon caused the tides on Earth. His major contribution to science and technology is the discovery of planetary motion. Before the planetary motion, there was the Copernican theory and the Ptolemaic system. The problem with the Copernican theory is that although his theory talked about the sun being the center of the universe, he did not talk about how the planets revolve around the Earth. While the Ptolemaic system was a geocentric universe, which meant that the Earth was at the center and the sun and the planets revolved around it. So what is the difference between the planetary motion of Johannes Kepler? Let's start with the three laws. The first law is called the law of ellipsis. It explains that every planet's orbit is an ellipse with the sun, where the sun is in one of the two foci. This was the difference between Johannes Kepler's planetary motion to the Copernicus theory. Because in Copernicus theory, it was perceived that the planets revolved in a circle. Now, the second law is called the law of equal areas. This law explains that the planets orbit faster when they are closer to the sun. For the third law, it is known as the law of harmonies. This basically talks about how the planets are separated and how it moves around the sun. It explains that the planets that are closer to the sun, for example Mercury, orbit faster, and for example, let's say Neptune, it will orbit the sun much slower. So, Johannes Kepler's idea of planetary motion, which later on helped in Isaac Newton's study about gravity. So now I will call on Mr. Castro to discuss about who are the key figures in helping this revolution.
These are the scientists who contributed to the revolution. Nicholas Copernicus, born in Toru, Royal Prussia, Poland, on February 19, 1473, and died in Frombork, Poland on May 24, 1543. He is a Polish astronomer who proposed that the sun is the fixed point to which the planet's motion should be referred, and that the Earth is a planet that, in addition to orbiting the sun annually, also rotates once daily on its own axis, and that the perception of the equinoxes is caused by very slow long-term changes in the direction of this axis. Heliocentric or sun-centered depiction of the heavens is named after the Greek word helios, which means sun. Copernicus' hypothesis has far-reaching implications for following philosophers of the scientific revolution, including Galileo, Kepler, Descartes, and Newton. Between 1508 and 1514, Copernicus came up with his primary concept, and at the period he composed a manuscript known as the Commentariolus, or Little Commentary. However, the Revolution Orbitorum Coelestium Libri 6 books concerning the revolution of the heavenly orbs, which contains the definitive form of his theory, did not appear in print until print 1543, the year of his death. Another scientist is Tycho Brahe, was born in Kynstrup, Sania, Denmark, on December 14, 1546, and died in Prague on October 24, 1601. He is a Danish astronomer who set the path for future discoveries by constructing astronomy tools and measuring and establishing the location of stars. Before the creation of the telescope, his observation was the most precise and conceivable, and it comprised a complete study of the solar system and an accurate position of more than 777 fixed stars. Another scientist is Sir Isaac Newton, was born in January 4, 1643, in Woolsthorpe, Lincolnshire, England, and died on March 31st, 1727 in London. He is a mathematician and physicist from England. He is the epitome of the 17th century scientific revolution. In optics, his discovery of white light's composition include colored phenomena in the study of light, established the groundwork for modern physicist optics. His three laws of motion, which are the foundation of contemporary physics, led to the development of the laws of universal gravitation in mechanics. He was also the first to discover infinitesimal calculus in mathematics. Another scientist is Galileo Galilei, was born in Pisa, Italy on February 15, 1564, and died in Alcantara near Florence on January 8, 1542. He was an Italian natural philosopher, astronomer, and a mathematician who contributed significantly to the science of motion, astronomy, material strength, and the creation of the scientific method. His formulations of circular inertia, the law of falling bodies, and parabolic trajectories signaled the start of significant shift in motion research. His instances that nature's books is written in mathematical language transformed natural philosophy from a quantitative, verbal account into a mathematical one, in which experimentation became a recognized method for uncovering nature facts. Finally, his telescope finding revolutionized astronomy and opened the path for accepting the Copernican heliocentric system. But his support for the idea led to an inquisition against him.
Hi and good day to you. I'm Eldin Friend A. Canimo from Group 2. So I'm here to continue our report on Johannes Kepler's planetary motion. So on the first slide that I'm supposed to report is a question: how did the revolution advance modern scientific thinking at that time? Before I answer the question, let us first go back to Johannes Kepler. So as we all know, Johannes Kepler is a German philosopher, mathematician, and an astronomer. Looking back, we all know that majority of the basis of studies we learn and we try to decipher up to this day came from ancient Greek. They were the ones responsible for the start of revolution in terms of these kinds of studies. Whereas many renowned people starting having their own ideas after studying the foundation built by the ancient Greek learning. Each revolution for each era has created a lot of breakthroughs and made a lot of new studies relating to the modern science and scientific thinking. Many would tend to question what others has published, thus creates another study and issue regarding the certain topic. This is how revolution advanced the studies on modern science and scientific up to this era. So on the next slide, after the revolution advanced modern scientific thinking, it made many influences on other studies by, of course, other scientists, mathematicians, astronomers, or even philosophers from all around the world, from Germany, Greek, from Romans, and all other person. As I have stated earlier, individual studies from individual person influenced each other to make more questions and more answers until they reach the same conclusion of a certain topic. Each of their ideas collide as some tend to agree with others and some has their own theories to prove. Johannes Kepler's planetary motion has become the influence for Isaac Newton's law of motion, in which he answered what and how gravity is applied using the laws of motion as a proof to his claim. However, starting from Kepler's study to Newton's, this is sparked another scientist to question another scientist's work, and he is the well-known Albert Einstein. Johannes Kepler's study were also used as a basis on one of Einstein's studies, the theory of relativity, which Einstein culminated by his own research and hard work collided with Newton's law of motion. His study presented how Newton's study only assumed that mass, time, and distance are constant, whilst his theory of relativity treats time, space, and mass as fluid things. So, this it doesn't mean that influences must follow the past studies up until to the latest studies. By influences, they can affect each other's studies, whether it may collide or it may somehow join with the claims of the other studies. So for the last part of my presentation, I am here to show you the impact of Johannes Kepler's study in different inventions. First is Newton's orbital cannon. So Newton's orbital cannon was at first an experimental thought, which is a key force in Johannes Kepler's planetary motion. Next is the movement of the orbit. So the planetary motion helped us determine the movement of the orbit so that we can predict the movement of each orbits, which includes our own planet and our neighboring planets. Last is application on astronomy. So as I stated earlier, Johannes Kepler is also an astronomer. So this study of his is or can greatly help most astronomers in predicting the alignment of the stars that they tend to watch and study. So that's all. I'm passing the next presentation slides to my group mate, Mr. Calletor.
So what controversies met the revolution? Johannes Kepler was commonly known for creating his most significant invention, the planetary motion, which included 3 laws. It explained that with the growth in the radius of the planet's orbit, the time it takes to orbit the sun significantly increases, according to the dictionary.com. Yet there are some controversies and historians become curious about it. According to E.J. Ayton in J.L. Russell's paper, he stated that Kepler discovered that the 2 laws are not equally identical. After the publication of the epitome Astronomiae Copernicanae, despite stating in 1609 that they were mathematically equal, it resulted in a controversy. His most outstanding Keplerian scholar, Max Casper, said that Kepler knew this in the first place, that the 2 proportions are not mathematically equal or identical. Furthermore, Kepler made some errors and in the calculations as he progressed through the 3 laws, and his results have a minor mistake to his predictions. However, Kepler continues to study and believes that accuracy is the main goal, and yet founded that the orbit should be described, and it was the equation of the ellipsis that helped him find the answer. And thank you. That's all.
So, before we end our presentation, the main takeaway is that Johannes Kepler helped advance different studies surrounding the field of astronomy. This also shows how impactful some studies are in upcoming studies by future scientists. This basically means that science and technology is timeless, and it is a collective work from every generation to the next. Again, we are Group 11, and thank you.